यहाँहरू सबैजना नमस्कार। म डिबी खड्का मध्यपश्चिमाञ्चल विश्वविद्यालयको फर्स्ट सेमिस्टरमा अध्ययनरत छु र आज मैले अब्स्ट्र्याक्ट अल्जेब्रा सब्जेक्ट कोड नम्बर म्याथ एडुकेसन 515 को लागि प्रेजेन्टेसन प्रिपेयर गर्दैछु, जसमा चाहिँ मेरो टपिकको नाम चाहिँ डिफाइन सल्भेबल एन्ड निलपोटेन्ट ग्रुप विथ इक्जाम्पल भन्ने थियो र जसमा मैले एउटा छोटो प्रेजेन्टेसन चाहिँ तयार पारेको छु, जुन यस प्रकार रहेको छ। सो फर्स्टली लेट्स टक अबाउट द टपिक first definition solvable. Solvable means a group G is said to be solvable. Group G लाई चाहिँ solvable हामी त्यति भन्छौँ if there exists a subnormal series. जति बेला चाहिँ subnormal series भनेर यहाँ हामीले G equal to G naught is greater than G1 and which is equal to greater than or equal to G2 and which is again greater than or equal to up to Gn and which is equal to identity छ र यदि यति सेटिस्फाई गर्छ यहाँ दिएका दुईवटा कन्डिसन्सहरू। फर्स्ट कन्डिसन चाहिँ के छ त अहिले GI plus 1 is normal subgroup of GI and again another condition is here GI by GI plus 1 is abelian। यो दुईटा कन्डिसन, एउटा चाहिँ यो नर्मल हुनु पर्यो, अर्को चाहिँ के हुनु पर्यो त GI by GI plus 1 should be the abelian and where for all I equal to 0 1 अनि 2 up to n हुनु पर्यो र यसको इक्जाम्पलको लागि चाहिँ हामी चाहिँ S3 इज S3 चाहिँ सल्भेबल हुन्छ भनेर लिन सक्छौँ। Likewise, my another definition is here for the nilpotent. So nilpotent is a group G if it has an ascending central series. Ascending central series is here that I wrote here. Identity equal to central and not z not of G is less than or equal to G1 of G and which is again a subgroup of a subset less than equal to up to Gn of G and which is again equal to. So that is the condition for nilpotent. And डिफो इज nilpotent. हामी यसको इक्जाम्पलको लागि चाहिँ डिफोलाई लिन सक्छौँ जो चाहिँ के हुन्छ nilpotent हुन्छ। Now my statement for proof is every nilpotent यहाँनिर every nilpotent group is solvable but the converse is not true. Every nilpotent group is solvable but the its converse is not true, means it's not solvable. So for this condition we can take let's be a nilpotent group then it has a series. यस्तो एउटा series हुन्छ, हामीले अघि डेफिनेसनमा पनि कुरा गरेका छौँ। सो यो series हुनलाई चाहिँ हामी के हुन्छ त E equal to G naught is less than or equal to G1 which is less than or equal to G2 and which is again less than or equal to up to G n, okay, and which is equal to G such that Gi by Gi minus 1 is less than Z of G by Gi minus 1 here and it for all I equal to Gi by Gi minus 1 is abelian. यो चाहिँ abelian हुन्छ because किन भन्दाखेरि यो चाहिँ किन abelian हुन्छ भन्दाखेरि यहाँनिर it's a because यो यहाँनिर चाहिँ के भयो त G by Gi minus 1 is abelian. Hence G has a solvable series. So the series, this one identity equal to G naught is less than or equal to G1 and is less than or equal to G2. Otherly goes up to Gn equal to G. So G is solvable. Conversely, S is solvable but not nilpotent because S3 is greater than or equal to A3 and which is greater than or equal to identity. Is normal series of S3. यो चाहिँ के हो त S3 को normal series हो and the factors S3 by S3 by A3 and A3 by identity are abelian. Thus, we have here the normal series of S3 is identity is less than or equal to A3 and which is less than or equal to S3. So, to be nilpotent, A3 by identity is less than of Z of S3 by identity. Here it's S3 by identity. So, S3 is less than Z of S3 and again A3 is less than identity there because Z3 equal to identity which is false. So S3 is nilpotent but its converse is not true. Hence the required condition is proved.